So in order to really get into REST, we need to understand a little bit about the HTTP protocol itself. So we want to look at the format of a request and response. There's always an initial line, then the headers, and then the separator between the headers and the rest is going to be actually a blank line. Then we get to what is going to be termed as the entity or the message body, then another blank line which gets us to the end of the request. So the initial line, what that essentially is going to look like is one line, space delimited fields. It describes the actual request itself. So it's going to have information about the actual HTTP method that's being invoked, and then the resource. Okay, so that's going to be a path to the resource, what you and I refer to as the URL, and it will also potentially contain query string information based upon the method type that you might be using. It'll also contain protocol version information, HTTP 1.0 or 1.1. 1.1 is by far the most common protocol that is being used on the web today. So our HTTP methods look like this. Okay, the GET method used for retrieval, though technically I can use the GET method to send information to the server. It just takes all the information and puts it on the URL line. The server is going to give back a body as well as header information, and it basically has the capability to cache all the responses. So it's assumed that if I'm making a GET request, what's returned to me is cacheable. Okay. Then additional information, as I mentioned before, can also be passed on the query string itself. Post, okay? This is for essentially sending information semantically. Though, as I said before, I can use a GET to send information to a server as well. But as far as aligning with REST, when I do a post, I'm actually sending information to the server. It is asking the server to take information that's based upon a certain URI, and then that information is contained inside the body of the request. Any response that I get back from a post is not cacheable, okay, because it's intended to be a response that is generated based upon the success or failure of the actual post itself, okay? So this is usually a form that initiates this, though in the REST world, this could be a simple post passing something like a JSON object, okay? And that post data is sent in the body of the request as what we call an entity. Okay, a put. This is also a send based upon a URL, and it stores information as a resource underneath that URI, and it's used for overriding. So when you think about the CRUD operations, this would be our update. Then delete. I don't think that needs a ton of explanation, but it's basically specifying that the resource being referred to is to be removed, is to be totally deleted. Okay, and this will return, a success or failure. Think of a SQL expression where the return is an integer based upon the rows that have been affected. So REST interactions with HTTP are like database access. They look like this: post, create, get, read, put, update, delete, remove, or delete. So what do our request lines actually look like? So if I'm accessing a top-level domain, like www.post.com, then my request line to perform a GET would look like this. Okay. If I was accessing a sub-resource, then it would look like this right here. So if I'm looking at, host.com, that URL, then it would look like this: get, URL accessing, and then the HTTP protocol that's actually being used. If I'm looking for dynamic resources, then a query string is going to be involved in it. Something like, Google doing a search request and passing a query string in, specifying also HTTP version. So that gives you an idea on what the standard request initial lines look like. The initial response line It's going to be a single line with spaced delimited fields, and it's basically describing the response, okay? And this is going to become very important later on in REST as you begin to use REST, is that part of the initial line that comes back is going to be the success or the failure of the request, as well as things like the protocol. But that response code is, for most REST clients, actually I say most, for all REST clients, is what the client is going to trigger on to determine if the request was successful or if it was a failure. Okay, it's a numeric value. It can be something that's standardized. In other words, there are several standard response codes in the HTTP protocol, or it can be something that your organization comes up with and maps different responses from the back end to a particular status code. Then there's also a description, which is some information about the code itself, you know, whether it's okay, failure, server error, client error, something of that nature. So let's talk about the 5 main categories of responses. There's informational, there's success, there's redirection, there's client errors, and then there are server errors. And we're all pretty much familiar with these just by our day in and day out use on the internet. So informational responses, this is negotiation based, okay? Status code are in the 100 series, okay? So anything from 100 to 199. You know, like 100 tells the client, hey, continuing with request. 101 tells the client, you know, adopt to this particular protocol. So this contains, you know, the status line and then header information as well as an empty line. Successful responses. So this is basically, I got your request, understood, accepted, and 200 is the most common. Okay, everything went well. The response body has been sent back based upon the type of method that was actually executed. 202, you know, is something like the client was told that the server accepted the request, but processing is not completed yet. 202 is interesting because it actually is the response code for doing asynchronous type operations with HTTP. There's actually several different APIs for working with asynchronous HTTP processing. 202 response codes are very common in that area. So this also consists of status line, headers, an empty line, as well as a response body, asterisk being there if there is actually an entity to be returned or not. Okay. So whenever you hear me refer to an entity, that's essentially the response body. That's where it's located at. Redirection responses. Basically, this is telling the client that to access the resource, you need to go to a different location. Common status codes are things like a 301, that the resource has been permanently moved, 307, temporary redirect. But all these, usually a redirection is something, unless you're writing the code to respond to it, that's handled almost without any interaction from someone using the client. It consists of status line, header, and basically an empty line, no body to that. Then we get to the exciting ones, the client error responses. Errors like this can be bad request. In other words, you send a URL that's not formatted correctly. 401s, you don't have access, okay? In other words, there may be no information in the header that provides the information that the resource needs. You can't access that resource. 403, 404, can't find the URI. 404 is very common in REST because I may have mistyped a service name that I'm trying to access, or I should say a resource. Method not supported. In other words, I'm trying to perform a post on a URL that only supports a GET. So that would be a pretty perfect example of a 405. And what these responses look like is this, status line, headers, and then also an empty line, no body. And then error responses. Something bad happened on the back end. That's the best definition of that. And they can be things like some unexpected problem took place, a 500. So this could happen as a result, for instance, of maybe performing a database operation on the back end that went bad. 503 would be, load-based issues. Many of us have hit this at different times on the internet trying to access a resource that's overly busy. 505 means the server doesn't support your protocol version, okay, or your HTTP version. And these contain status line, header, and empty line. Okay, so these are the most common responses that you're going to get back. So let's look at examples of what these look like. So on a top-level domain like host.com, there's what a 200 looks like. That's the actual initial line that you get. And again, to emphasize something, when working with REST, we like that initial line because I don't have to dig into the body of the request to see exactly what happened. I can look at that status code to determine. Here, I might access a, sub-resource. So 404 return, not found. So again, right on the status line, I can tell what happened. A redirect, accessing this, 301, because JavaSoft has been totally moved, right? So 301 moved permanently. Let's talk about HTTP headers, because the headers essentially become our envelope, if you will, equivalent from the SOAP world and the REST world. But these are all meta information about a request. So it can have basic information about capability, it can have information about where the request came from, when it was created. So it can be very descriptive and very useful. And plus, you can extend it with your own header information. It's used for both request and responses, and it's all just name value pairs. Okay, and the syntax is very, very simple. Name and value. Okay, and the value is text data. I would say 99.9% of the time. All right, so typical request headers. Probably the most common, or one of the most common, is the accept header. And it's basically the client saying, hey, this is the type of data that I would like to have back. In other words, the content type that I would like back. The beauty about accept is there can be multiple accept entries. So I can, as a client, I can specify I want JSON and I want XML. So it's just a comma separated list of different MIME types. Wildcards can be used in the process as well. User agent. Okay, this is the client software. Probably one of the most common headers that we always like to program to. This is access logs, pick this up. I can also trigger off this to generate a response that a particular browser type can understand. Refer, where did the request come from? This is used quite a bit on the internet today. Whenever I'm linking from one site to another, that gives a refer information to tell the server where it came from. This is often used for search engines for being able to detect origin. Age, time since response was generated. Okay, this can be used by proxies and cache servers that sit in between clients and HTTP servers. The server header describes the server software particularly in use, whether it's Apache or maybe something like IBM HTTP server. And then there's also entity headers that can be used to describe what's in the message body. And these are used in both request and response because with a post, I'm actually sending in an entity in the body of the message. In a response from a GET, there's going to be an entity in the response. Allow basically specifies which HTTP methods are supported with that. Content language, it's the language of the content itself. I think that's kind of self-explanatory. Content length, how big the content actually is. And then content type. This is the equivalent of accept. Okay, so whenever the client sends content to the server in the content type header, it will tell the server what the type that's being sent is as it goes to the server. So if I'm sending XML or JSON, it's used in the response to tell the client what the content type the server is sending back to the client. Okay, it's a MIME type representation. There's also an expires header that will basically specify when anybody that's caching the content should consider the content dead. In other words, out of date. Okay. Last modified. It's when the last modification date is of the content itself. Okay. So let's move and look at the HTTP entity. This is the body of the payload. So this is associated with the request or the response. It may or may not have any information in it. Okay. It totally depends upon the HTTP method that's being used or the type of response. And the header information that you just got through looking at determines things like the length of it and the type of it. Okay. Also, any encoding information that needs to be specified with that. So these headers, for instance, if I'm sending back a PDF file, the header information will notify the browser or the client that what's coming back is a PDF. And if you have a program that knows how to read PDFs, launch it to read this content. Okay. So the server can take action against an entity if I'm doing a post, in other words, process it. It can store it or it can totally ignore it as well. The client can do fairly much the same thing. It can render it, it can store it, or it can totally ignore it as well. So let's look at an example on a post request. So this is what the client requested. The entity contains this. So this is what that thing would look like. Okay. So it's a post doing a search, google.com. I'll accept an encoding of gzip. In other words, that's the encoding type that I can take if you're sending me back any type of archived information. And you'll notice the accept type basically is saying anything. Remember we said that it could be wildcarded. The languages are in order of preference. The user agent information basically is client information. This is who is requesting this or actually sending this. And then the content type is basically a form, is what's being passed. And there's my length on the content that's being sent. And you'll notice that the content is very, very simple. It's just a field called Q, and its value is John. Easy squeezy. A response entity example comes at the response of maybe a request like this, google.com search, Q equals REST. So I'm looking up REST. So here you'll notice that the response comes back. It's just it's a 200, okay. Content type is HTML. The server is GWS 2.1, which is Google's web server. The connection's been closed. In other words, it hasn't been kept alive. Then we have our blank line. Then we have the actual body or entity of our content, and that's all of our HTML. And you'll notice it has just standard HTML information in it. Okay. It also has all the style information as well as any script information included. So that gives you a good overview of both REST and general HTTP interactions back and forth to the server. Now prepared you to look at REST in your language of choice, whether it's on the .NET platform, if it's on the Java platform, if it's done on the mainframe. Now you have the basics of the infrastructure that REST operates in. All right, let's take a look at JAX-RS and its implementation. JAX-RS is part of the Java Enterprise spec. It provides all the APIs for REST web services. As of Java Enterprise 1.5 and later, we now have a specification for REST web services inside of Java Enterprise, which is a good thing because now we have a common API that we can write our code against instead of being implementation specific. It's not part of Java Standard Edition. It is part of Java Enterprise 6. Current version of JAX-RS is 2.x. And I say 2.x because it's evolving pretty quickly. 2.0 and 2.1 are the ones that we see in production the majority of time at this point. If you're building new REST web services, you definitely want to be focused on JAX-RS 2 and an implementation that follows the 2.x spec. The beauty about it too is it's annotation-based development. Gone are the days of a bunch of XML and having to do this all with inside of either WebXML or some other configuration file. Now everything can be merged directly into our code base thanks to Java 1.5. So annotation driven is the way to go. And as you can see, the reference implementation is Jersey. There are many implementations of JAX-RS. Jersey is probably the most common one you'll see in use. Jersey is the reference, just like with the other spec in Java Enterprise. Not only do they provide the specification document for you, but they also provide the reference implementation to show you how one implementation of it might be actually put together. Jersey is available at jersey.java.net, but it's also available as part of Glassfish. Now, there are other implementations as well, and probably the other most popular one comes from the JBoss community. So if you're a shop that uses the JBoss application server, then REST probably would be the implementation that you would be focused on. If you're a shop that uses Glassfish, obviously Jersey is going to be your implementation. If you're a shop that uses Tomcat for your production environment, then you really have a choice. You can either go Jersey or REST. My experience is that the majority of shops that are deploying on Tomcat, Jersey is the most common implementation used, okay? And JAX-RS currently says it's only server-side, but actually that's as of 1.x. With the 2.x revision of JAX-RS, we now not only have server-side spec, we also have a client-side specification. So gone are the days where I have to use something like Java's HTTP URL connection or the HTTP client by Apache. There's actually a full-blown client API that's now included in JAX-RS. Only thing that we need to make sure is that jars are on the class path, and we're ready to rock and roll with JAX-RS. Oftentimes, and I would say the majority of the time, a JAX-RS application is deployed in container. In other words, it's actually deployed to an application server like a JBoss, Tomcat, Glassfish. There is the option, though, that I can run these JAX-RS services with a tool like Grizzly, which is a non-container oriented runtime, so that I could literally test and run REST web services using something like that instead of deploying to Tomcat to see what their functionality is. Jersey also provides a standalone implementation that's available if you want to use that, but like I said, the majority of the time, as we will use inside of our demo environment here, we'll actually be deploying to Tomcat to test our web services that we actually develop. So in summary on this, JAX-RS gives us an API spec that these implementations adhere to. The idea is that I should be able to write my code against that specification and then deploy it in Jersey, have it function just fine, have it deploy in Glassfish, where Jersey is implemented just fine, be able to deploy it in JBoss on REST. Should be no issue there as long as I code to the API, and I'll stress that as we write code together from this point forward. So at this point, what we want to do is get to the code, right? That's what we're here for, is to actually get to the code, look at implementation. So from this point forward, we're going to spend quite a bit of time inside of Eclipse, actually iterating through complexity of building a REST web service using the JAX-RS API. Again, we'll be using Jersey as our implementation and deploying to Tomcat. Okay, so the environment I'm operating in is Eclipse Kepler. Obviously, Eclipse Kepler, for those that are in the know, is not the absolute latest version of Eclipse. We're 1 year behind. Luna is the latest. But all these demos, all this code that's being developed is known working inside of Kepler. Have run it a couple of times inside Luna, which, you know, it seems to function okay, but it's best to stay one iteration behind just for the sanity's sake. I can tell you that you don't really want to be on anything earlier than Kepler in doing this development, because we do rely on MAVEN for pulling in dependencies. So the first thing that we're going to do is create a project that we can begin our development in. So brand new project creation, And the project type I'm going to create is a MAVEN-based project. And make sure that these fields are blank. We don't want the MAVEN plugin to try to put this stuff in a location that Eclipse is not going to like. And the type that we want, as I can come in here and filter for it, is I'm interested in a web app. Okay. All right, so the first thing that we're going to do here is fill in some of the basic fields on a MAVEN project. And I'll say com app dev rest, and artifact ID is going to be I'll call it rest project, and package is going to be com.appdev.rest, and that gives me everything that I need right there. So I'll click on finish. Project will be created. Okay, while that's creating, next thing I'm going to do, just to make sure that we have an application server to deploy to, you'll notice that I went to my servers tab inside of the Java Enterprise perspective here in Eclipse. I'm just going to take the shortcut route to do this. I mean, there's multiple ways to integrate a server into Eclipse. We're just going to take the easy route. So I'm going to click on that link inside the servers view. I'm going to go to Apache Tomcat 7, right, because that's the kind of server that we're interested in, and go to next. The default runtime is going to be a Java 7 runtime. The only thing that I need to specify here is where Tomcat is actually installed. And you'll notice that all this for me is located directly off my my C drive. Okay, so I just select the root of it, click OK, and click on Finish. Just take the defaults. So excellent. So now I have both my server set up and I have a project, and you'll notice that project at this point in time has a compilation error in it, and there are a couple of reasons for that. So let's take care of those compilation errors. If I open up the POM file for this project, because again, MAVEN-based project, it's going to be built on POM. You'll notice that my dependency section, and I've got, yes, both dependencies and build highlighted, but dependency section does not have any Java Enterprise dependencies in it, nor does it have any of the Jersey or REST API dependencies included in it. So we need to take care of that. To make it easy on you, because we deeply care about every single one of you, is we provided a fragment for the POM file that has all the dependency definitions in it, so that we can just copy and paste that in to take care of everything that you need for your REST development. So I'm going to take this entire fragment from dependencies all the way to the bottom, and if you go to the bottom of it, you'll notice it has the build definition in it as well. Copy the whole thing. Make sure I get that closing tag. And I just want to take this highlighted area and replace it. So there I go. So you'll notice I replaced build all the way up to dependencies, right? And using the Control-Shift-F command keys inside of Eclipse, able to reformat that. You'll notice as soon as I do that, down in the lower right-hand corner, Eclipse start the build process. And one last thing that you'll notice is I still have my little red X there. If I right-click, MAVEN, Update Project, that will synchronize my MAVEN POM file with my Eclipse project, and we should be good to go after Eclipse gets done building. And that will take care of all the necessities for building REST services inside of Eclipse Kepler. Yeah, because Eclipse does take quite a bit of time sometimes to initialize a MAVEN repository. We've made time pass in ultra-fast fashion so that we don't have to wait around for that to take place. One thing that you probably will need to do, and it's not a bad idea, right-click on your project, run as, do a MAVEN install on that, and that will just make darn sure that all is right with this project. It'll do a MAVEN build on it. You'll notice down in my console, down at the bottom, build is successful. So that basically means that everything that I need now to continue on with REST development is now part of this project. Another way to validate that, under Java Resources, Libraries, you'll now notice that MAVEN Dependencies has quite a bit in it. Before, all it had was a JUnit jar file in it. Now you'll notice all of the dependencies that are included. And I'll quickly browse through those, show you that. There's the RS API, that's the REST JAX-RS API classes and interfaces. There's the annotations for building web services, REST web services that we'll be doing here. You'll also notice that there is the Jersey implementation, right? That's all these files that begin with Jersey. And then you'll also notice that we are including Jackson as our provider for JSON. So looks like we have everything that we need to start building web services then. So let's go ahead and do that. All right, so I have source main. I go in and add my Java folder here so that Eclipse will pick that up. You'll notice it picks it up now, source main Java. And I will refresh this so that everything is organized the way I want it to be organized. And so with source main Java selected, right click, new, and a brand new class. Okay, so what I'm going to do is I'm going to build a path to a web service that has a version in the actual path to the resource itself. So I'm going to call this app config. Click on finish, and I'll use my text editor here to kind of show you what I'm going to do in a comment. So here's the path I'm going to be building, okay? So it's going to be my host, obviously port, / project name, which is what? REST proj, and then this is going to be v1, then resource. Okay, it is a best practice to include the version numbering of your REST resources in the actual URL. Unlike SOAP web services that have a fairly robust versioning capability in the methods, that really doesn't exist in REST. So we want to actually indicate on the URL what version number this API represents. And remember that everything in REST is a resource, just like everything on the internet, HTML file, some CGI bin program that you'll call on a website. They're all just resources that the internet gives us access to, that HTTP gives us access to. So that's essentially what we're going to mirror, and we're going to put the version number in that URL. So in order to do that, what I want to first introduce is the concept called an application. An application in REST is just a grouping of resources. Now, is it an absolute requirement that I have an application? The answer to that is no, there's not. I could just go in, create a bunch of resources, and Jersey would automatically find those and make them available to me. What the application gives me control over is being able to put the version number there, as well as the life cycle of how these resources are actually created, which is something that we will focus on as we move through the building of our REST service. So I'm going to use the application path annotation. Okay, if you remember, JAX-RS can be totally annotation driven, and I'm going to put the V1 right there. So now I have an application with V1 as part of the path to indicate what version all these resources are. Now to have Jersey, or I should say JAX-RS, because I could be using REST-easy, pick this up as an application, then I want to have it extend application. And I'll use the Control-Shift-O inside of Eclipse, automatically bring in the import. Be careful. Notice that one of them is the WADL, one of them is the JAX-RS core. We want the JAX-RS imports. That's what we're focused on. So in other words, these are elements that are in the actual JAX-RS API that I want to write my code against. Nothing specific to Jersey at this point, nothing specific to any other REST implementation. All right, so I've got my application set up. There is a method in the superclass application that I want to provide an override for that gives me access to REST resources. I'm also going to close this outline view over here just because it's kind of in the way. It gives me a little bit more space to write my code. Right click. I'll go to my source, override implement methods, and you'll notice that there is the method that I care about. It's called get classes. So essentially what this method is going to do for me, it's defined in the application class that I'm extending. When REST starts up, whichever implementation I'm using, it's going to detect all the applications that are on the class path. For every application on the class path, it's going to call the getClasses method to get a list of all the resources that application manages. I'll click OK, and you'll notice that it automatically, I love it when Eclipse writes my code for me. It automatically creates that method, and you'll notice that I have a set of class types that are returned as a result of this method call. So all I need to do is create an internal field inside of my app config to hold all my classes. So I'm going to go ahead and use that as my declaration. Do this, call it resources, and I tell you what, let's use a new hash set, okay? And using the good old Java 1.7 annotations, you'll notice on the right side, I don't have to declare it as a particular type. It automatically infers that based upon the left side of the assignment. And then down here, instead of returning super.classes, I do not want to return the result of a super class call. I'll return my resources. Okay, and I can also get rid of that to do there. Last thing I need is for Eclipse telling me something else I need to get done. So the next thing I want to do is add a resource. I don't have a resource at this point in time. I have an application. That's all great. I have its basic infrastructure in place. So now it's time to add my first REST resource. And I know, like you can feel the excitement building. So here I have a brand new class, and I'm going to tap into my deep creativity, call this R1 for resource 1. Click on finish, and so this guy is going to actually now turn into my first resource. Before I go ahead and provide all of the JAX-RS annotations that identify this as a resource to Jersey, what I want to do is hook it into my application. So, I'm just going to add a constructor here to do that. App config. And I'll say resources.add, and I believe it's r1.class. That's the name of our resource. So excellent. So now what I have is I have my resource hooked into my application. Excellent. And I'll also, just for kicks, I'll add a system out in here so that you can see when this application is actually created. So I'll just say created app config. All right, so back over to R1. So this guy's really done. It will automatically be detected by Jersey because it's on the class path, recognized as an application. REST will call this method to get a list of all the resources, so I'm good. So now I can focus on my resources. So in order for this guy to be identified as and used as a resource, I need to annotate it with a path. And so I'm just going to follow the name of the class just because it makes it easy, or I'll call that R1 as well. And I'll bring in the imports for it. So you'll notice again, and I'll say it many times, I'm focused on Java X WS-RS as my imports. I don't want anything specific to any implementation of the JAX-RS API at this point in time. I want to stay generic. I want to program to the standard. So now I want to do is add, I guess, what we would call an endpoint. So I'll say public. Let's say we'll have it return a string. And just like all good software in the world, it all begins with hello world at some point in time. So I'll format that, and then I'll return a string on that. So I'll say return hello world, like that. So now I have my basic resource method in place. The only thing that I need to provide at this point is I need to tell REST what HTTP method that this Java method is going to respond to. So I have the path down to this point, project/v1/r1, but I need to say, okay, whenever a GET request is executed against that URL, I want this Java method to respond to that. So I'll just add the @get annotation, bring in the import for it, save it, and lo and behold, I have my first basic JAX-RS service ready to begin testing with. So now I'll take my project and actually run it on my Tomcat server, and you'll notice that it comes up by default. I'm going to select that option down there so that I don't get this dialog every single time that I try to run this project. I'll click on Finish. And you'll notice that Tomcat starts up. And I'm going to go back to the console real quick because I would like to show you something. You'll notice that this is all basic Tomcat startup information. You'll notice that the Jersey application servlet is actually started up, and then you'll notice my system out print line from my app config actually shows up there. So what you just found out in regard to the life cycle of REST is the applications are created at Jersey startup time. Okay? And then from there it just goes on to register it, and then register any resources that that application refers to. The internal browser inside of Eclipse then automatically brings up the default web page for this project. This is not the REST method call right here. This is a result of a JSP that's automatically created whenever you create a project based upon the web app template using MAVEN inside of Eclipse Kepler. This is a nice thing to have, by the way, because it at least tells me that my project deploys successfully. Whether or not my REST service works yet or not, at least I know that the project itself deploys and actually runs, and I can get a response from it. So now it's time to run the actual REST service itself. And so you'll remember the URL pattern is the project name, v1, our version number, /r1. Enter. Lo and behold, there you go, your first basic REST service. So based upon this URL right here, the request comes into Tomcat. It sees that it's a URL destined for REST. The app config has already been registered. All the resources have already been basically made available to Jersey. So it basically will look and find out that this resource, this application v1 has an R1 resource in it, finds that path, and then you'll notice that that's where the path ends, right at R1. And so the next thing it's going to look for is what I would say is a default Java method that's going to respond to a GET request. It's this one right here. And so that is executed, and the return is sent back to the browser. Thus, there is my hello world. Okay, and I'll go ahead, by the way, and turn on line numbering just so that we have that for easy reference as we move through several other examples.